What is up, YouTube? So, on popular demand and suggestion, I decided to go live anyway tonight for a little bit to do a classified call-ins. So, anyone who's got scientific or technical knowledge or intelligence or anything they want to share with the community, call in, open lines, jump on here. Please don't, shout out any obscenities or you will be, kicked off the stream immediately and blocked. But, try not to, no trolls, please. Just some solid people with intelligence and smart people. In the meantime, you guys can check out the Unlab. There's some really cool presentations in this Unlab from these guys. Garrett Modell is definitely one to check out. And also George Hathaway, Daniel Sheen, he's been on APEC before, and Nathan Innen, always a really interesting and smart guy. A lot you can learn from these people. So definitely go check out George Hathaway, cold fusion stuff. Doesn't have a lot of views, but yeah, go on this channel, check these things out. In the meantime, David Gould, what's up? Here's the StreamYard link, guys. We'll get some people on here, and you don't have to share anything classified if you don't want. You don't have to, get yourself in trouble or nothing. And if you do, you can come back and change your name and jump back in. And put a voice mod on or whatever you want to do. And yeah, come on and share some interesting stories and some interesting information and stuff with us. We're going to be hopefully getting some interesting people on here to share some stuff. What was I going to look up? I wanted to put on some stuff. Well, let's just do a deep dive on the drive, man, and we'll go over some of this Lake Marabou stuff. I'll start with there. We'll start with a scientist working on some really cool Project Skyvault microwave laser powered magnetohydrodynamic generators for space applications.
Wow.
This is a NASA technical paper from 1986. Langley Research Center, Hampton, Virginia. So this is NASA's and the CIA. They did MHD theory, laser plasma interaction, plasma production, plasma heating, candidate magnetohydrodynamic systems, pulsed LSD systems. I don't think they mean
right. Yeah, I know. Not what I like to think. Not
taking up LSD, you might have some pulsating plasma systems going on. Liquid metal systems, Brayton cycle, Rankine cycle, summary and recommendations. Yeah, so MHD theory talks about, there's our equation where B is the magnetic field, K is the ratio of load to open circuit voltage, V is the flow velocity, Larmor radius, and the plasma conductivity. Ooh, interesting stuff. So here it is. If people, don't want to have to figure this stuff, this is what they pay scientists the big bucks to figure out. Engineer. How do you engineer this stuff? Give me some equations. Well, here you go. This was all classified at one point. I mean, it some of this stuff maybe not. But yeah, and then you get into this. Lots of cool stuff. Lots of cool. Oh, Lake Marabou wrote a paper with this guy, Craig Maxwell. Who's that? Well, let's look him up. You can find out some of these other interesting scientists and engineers who've worked on these programs and get some information about them. And that's how I do a lot of my research, is finding papers like this and then digging through these bibliographies to find more papers like this so that I can dig through those bibliographies.
There we go. Got it.
And so on and so on. And that is called the deep dive dig. I want to play some of these videos, and these were like on TV and in movies and stuff way back in the day. I gotta find. So where's this? I'm gonna open location.
Some kids did a cool high school experiment where like they had like some I don't know, paper or like some type of object that they threw in the air, and like there was at least about 50, I don't know if there was like 100 kids or 50 kids, but they all had laser pens and they all hit the object at the same time, and it actually propelled the object further in the air. And that's pretty cool.
Check this out. They do it. They spin it up to get it give it some angular momentum with the air compressor.
Oh yeah, that was really big.
These are some of the bad tests and stuff too. Yeah.
In fact, that might have been actually done in. Yeah. A lot of folks think that's how we're going to get to the stars. That same technology. What are your thoughts on cold plasma and single wire electricity, Jeremy? You think there's something to that? I think there is. I think as long as you can get an angular momentum and really put a spin on that stuff, you can get some lift out of it.
Maybe. Oh, they were doing experiments with this. I mean, this was the dream that they had, was to be able to, to be able
well, it's not a dream. That's real science right there.
Yeah.
And that's wow.
See this right here. So see this right here. This is the concept.
That's the only way we're ever going to get to the stars is that technology right there, using lasers.
And you see how they were doing it, right? So they had it projecting from the disk itself to a point in space ahead of the disk, and you see it's causing this supercavitation effect that the disk is going into.
In front of it, yeah.
And where did that technology go to? It didn't go to bringing us to space. It went to bombing our enemies.
Yeah. Well, I mean, what do you expect a bunch of banksters and mobsters to do with it? They just want to confuse everybody and make us so fearful we can't figure shit out.
So what's up, guys? I'm gonna do a deep dive. We're gonna talk about stuff that but did exist and was going places, and then it just disappeared off the radar. And the scientists now we reached out to these guys, and they're under NDA. They can't talk until 2027 or maybe even later because the stuff's classified now. And
well, it's a good thing you're not talking to the pharmaceutical industry right now. We've got to wait 70 years to hear anything about the COVID. I mean, come on, it's fucking crazy.
It's because.
So there's something stinky with that freaking vaccine.
70 years, you'll be dead. Like, okay, why is it like a human, the human life expectancy now?
Yeah, they expect everyone to be dead by then, so then they can release it. Kind of makes sense. So that's how dirty that shit is. Well, I'm sorry to interrupt, dude. I'm sorry.
Oh yeah. Well, no. Hey, man, speak your mind. This is the thoughts and views expressed by my callers and people who come into the show, are not necessarily those expressed or shared by myself. And to each their own. And we try to bring, I'm not afraid. I'm real on this show. I don't try to be fake to try to get views or
I could see that you're genuine like that. I am too. I don't expect everybody to agree with me.
I got some crazy friends that believe in that.
I want to listen
and all kinds of nonsense. So I don't have to agree with everybody, and I'll let everybody speak freely, because that's how we get around it,
Well, yeah. If someone disagrees with me, I have to listen because I might be wrong or there might be something I'm missing.
Forward.
Look at the size of this one.
Rapidly pulsed. The engine is continuously propelled on its way to orbit. Why should astronauts have all the fun? I want to go to space. I can't afford it. It's too expensive. I could afford it if it was for the price of an airline ticket. And that's why I'm developing lightcraft technology, because it would open up space to everyone.
There's even a second generation of ideas about beam-powered spacecraft. Close to the Earth, The craft converts sunlight into electron beams that spin like a fan, moving it in any direction. Then it flips over. An orbiting solar power station hits it with a laser or microwave blast to generate 9 billion watts of electricity. This powers a remarkable engine that pushes air downwards
9
and
billion.
even pushes the atmosphere out of its path. The 60-foot craft and a dozen passengers could reach the moon in just 5.5 hours. A solar-powered, virtually free ride.
That is a lot of blunt force.
So does it have to send the light in the front of it, or can the light just be bent around it through the material on it, or whichever?
Well, it's beamed at like a certain area, like in front of the craft. I'm sure that distance, that focal point changes, depending on the velocity that you're traveling. Because if you're going really fast, you're going to want to put it like further out in front of you, than if you're going slower. You know what I mean? So,
Yeah, that makes sense. I was just thinking how
Wouldn't that create
the
a
beam.
ton of ozone? I mean, wow.
Oh, this is a newer video. Let's watch this. Progress. It was a 20-minute one. I don't know if we're going to watch the whole thing. This might be classified, guys, so I don't know about...
By a factor of 10. Complexities associated with having multiple stages.
So these guys
Roughly
do a
where
whole-
Goddard was in 1930 or so.
Yeah, they're talking about implementing
So we
this
managed
stuff.
to rockets. We've talked about continuous wave, which goes hand in hand with a heat exchanger approach. Pulsed sources go hand in hand with pulse detonation engines. So it's different physics that you are powering.
That makes sense.
Let's watch this. This is good
With the
because
sources.
this
So
is a
on the
little
left
bit
is the
beyond
laser light craft of
2018. Here we
Lake
go.
Mirabeau, who I should say was the co-PI of that last program that I showed you. So Lake and I worked together on the microwave stuff as well. And on the right-hand side is the microwave rocket of the Komurasaki group in Japan. So the way pulsed rockets work is they are fundamentally a pulse detonation engine cycle. You absorb beam energy, and there is a plasma that grows. And as that plasma, as the plasma density increases, that plasma starts to increasingly reflect the beam. So it can't be a steady state cycle, but it then explodes. It's a laser or a microwave supported detonation, and the propellant from that propels the rocket forward. And I'll show you a video of that in a minute. But this is the engine cycle. You have a discharge that starts at the top of the rocket and works its way down. And then you have a lot of whatever the propellant is expelled from the end.
Oh, welcome, Jay.
This video of the microwave rocket operating is slow motion.
Yeah, look at that. They're just blasting it with the air. It's like flaming up.
Wow.
Slow motion system. So welcome, Jay. Hey, if you got anything you want to share or drop on us, let us know. Like, feel free to unmute. And
Kobe.
again, link in the description below this video to anyone who just joined. If you guys want, I just posted it down below. If you go to more info underneath this video, you can get the link and you can join up, and we'll switch gears to whatever topic you want to talk about, man. If it's if you're over the light laser craft stuff, lots of people have done experiments into this now, so it's kind of old news at this point. There's lots of methods and experimental setups, designs that they can see.
Well, what about the use of?
Think about when all the triangles started appearing and when this research was being put out, and then it kind of like, you know what I mean?
Didn't think of that.
I never thought about it either, but it's like people were seeing these triangles, and I'm wondering if they were like.
It kind of seems like a ground.
Oh, it's sucking it up, right? It's beaming the energy from space. Oh, I get it. It's kind of like, yeah, all right, I guess.
Do you have anything on like holograms as being like to provide different effects on altering the atmosphere?
Well,
alter the atmosphere as it is.
yeah. So in addition to these lasers that can cause these blasts, that can, you put the blast underneath the hull of this craft, and you can kind of propel yourself with it. But in addition to that, there's also those lasers that can create the displays in the air, right? So
Yeah,
Yeah.
the pyramidal things you see over China and Washington and all that, those are definite. Those aren't UFOs. It's obvious. You can tell one of those holograms versus something that isn't really there.
you've seen this, right?
Patel scientists have finished testing on an early weapon that can make laser plasma balls talk.
Oh, yeah.
It's called the laser-induced plasma effect, and it's made by the Joint Non-Lethal Weapons Directorate. So what they've done is basically created a laser that can shoot out to a certain distance, and they can pipe in sound waves through it, and actually make human voice sounds and commands. Where this becomes useful is around an area we want to keep a perimeter secure. So essentially, you can shoot out this laser. You can then talk to the people on the edge of the perimeter rather than sending troops out there and tell them to get away, or you're going to shoot, or get away, or they're going to use other means to deter them. And that same laser can be used to actually target the individual and create heat through pinpricks, like microscopic pinpricks in their skin, even beneath clothing. It's extremely uncomfortable, and people move out of the way almost immediately. At the same time, the exact same laser is also being used as kind of a never-ending flashbang grenade. It can basically, with a power source, it can constantly create audible effects to deter and confuse and disorient people, just like a flashbang grenade that you would have in your kit, but would only be able to flash once, maybe twice, depending on the design. Now, it's still a few years away. They just finished testing to get the audio portion through the laser in a laboratory setting this year, but they expect to have a fieldable version within the next 5 years that troops could use to protect different areas or put on mobile platforms to disperse crowds or use it in a non-lethal way in theater.
Or if you use microwaves and just a hard, strong open light source, you can broadcast your voice to a lot of people.
So this is a video by XLaser USA, and
if all the research pans out in terms of developing fusion, we'd have a clean energy source that would last for thousands of years.
Nike is a world.
Oh, so they're doing laser plasma research at U.S. Naval Labs too, SPAWAR, and really interesting stuff. Let's bring that other window back though. Yeah, this one.
Hey everybody, Adam at XLaser here. Today we're going to give you a quick overview of the different parts of a laser light show projector and how they all work together in order to create these kinds of effects through the air or on a wall. Sine wave on the x-axis, but at a 90-degree offset, you can see that now we're moving the beam both up and down and left and right at the same time, which is making it draw a circle. This circle is being drawn at a rate of once per second, or 1 hertz. If we double our speed, so 1/2 second per cycle or 2 hertz, you can see that the line is much longer. It's no longer just a
so it's
control
like
this position.
So it's vector plots. So you could if you get funky with your vector plots, man, you can program in some really cool plots and get these things to display some cool things. So that's not quite what I was thinking. This was. I'd like to see. They have a video. It was from CE5 Japan.
If we had a
CE5.
Are you talking about that concert, laser hologram?
No. This was at like an electronics show over in Japan, and they were showing off this technology, and that's what I think, like, that's the last I ever heard or saw of it, because it just like it disappeared after that. I haven't seen the video. It's like hard to find. I've shown it a couple times on this channel. Like I try to show it and like talk about it once a year or so, bring it back up again. But it's one of those things. It's like, yeah, you go to look for it and now it's gone, dude. They have all these laser light projectors and laser and light shows and stuff, but this ain't nothing compared to what they can put on. They can make a tic tac right in front of you, make it fly around, make it and then put it on radar too. So they can fake the radar.
All I remember is they had
That's too much, man.
I remember they had a Tupac singer dude that was moving in real time, and I remember that. Or I think it was Tupac.
Oh no! You mean that like that dude when the riot broke out in Texas a while back?
No, that's a whole nother. I lived there. That I don't know all about that, but I'm talking about back in 2011 that one of the singer holograms were shown, and the guy was going on, and it looks so surreal. Like they actually have an anime version, girl one in Japan. You could probably look up. I don't know if you could find it, but yeah, they're pretty advanced. I mean. But yeah, the event over here, yeah, they said a lot of weird stuff would happen. So that the guy's face supposedly they claim was morphing. So I don't know that everybody would probably already have done research and knew what everybody was saying about that. So I'll just leave it at that. You can stretch your imagination with that.
Yeah, some of that Dave Icke reptilian stuff. Morphing.
Pretty much, yeah.
So let's a lot of this light craft stuff, guys. I had the copy of the book too. I still have a copy of it. It's no longer up on the site here, but a lot of cool stuff with the let's go find another topic here. Ooh, maybe some Lockheed gems. Should we do that? I'm gonna wait for Sean to get on here and dig into some of that stuff, dude. Let's get some random stuff out of the unsorted bin.
Thing was screwing up again. Can you hear me now?
There he is, man.
Yeah, son of a bitch, man. Sorry, I've been trying to tell you freaking details this whole time and none of it got through. Go do yourself a favor. Go back to the main folder. Just back out of that. Go back to the main folder. Go to Patel Energy.
Patel Energy.
There it is. Let's see, Patel Energy. Yeah. Okay, dude. Look at the fucking title. I'm sorry. Look at the titles of the few documents that are in there. I've tried to find them via Google. You have to do number direct. Okay.
Oh yeah, is this the hafnium shit?
Oh, it's better than that. Not this one, man. This ain't even it.
Oh, you got me excited when it said gamma ray thing.
Yeah.
No, go to the other ones, man. This one is just okay. Just go straight to the positron generator. Go ahead. You wanted to talk about graphene and surface charges and generating virtual charges and separating them. Now go ahead and open that. It's in that Patel Energy drive. But you should be able to hit forward once on your arrow on your navigation. Yeah. So yeah, you want to open the one on. Let's read the titles, man. You're gonna see this is stuff that you're talking about already. It's there.
Patel Energy Alliance. All right, so this is antimatter electrical generator.
That's one of them, and you might want to take a look at the positron generator and storage mechanism.
System and method for storing energy. Ooh.
It's juicy, man.
Storing positrons. Okay.
It's not complicated either. Does that start to look like PAS to you?
No. Not really.
I'll look again. It's all related.
Yeah.
It's the same metric. You're stressing space-time itself. You're really stretching out the boundary conditions of the virtual charges and breaking the Schwinger limit.
That's where everyone, they say, oh, something at that fast, all the G forces and this and that. None of those people think about the time boundaries and the non-inertial properties that get involved with a lot of this technology.
I want to go back to
I
that
think
Sal
I
page.
snapped that one so I can check it later.
If you were looking for the secret sauce, there it is.
Sauce.
Yeah.
That's the secret sauce right there. It's positrons. It's secret sauce.
Mm-hmm.
Yeah,
it is though, man. I'm not.
Okay. The whole idea is it leads to controlled motion of electrically charged matter from solid to plasma states, subjected to accelerated spin and or accelerated
momentum. That's what I was saying. Plasma and
via
Ramanauskas just nailed it, man. Exactly. You move space, not through
gives
space.
rise to high
Nailed
energy
it.
electromagnetic energy fluxes, which are commensurate to high energy densities. Hence, it is possible, in my opinion, to achieve the Schwinger limit. That is, electromagnetic energy fluxes.
And by achieve, he means break through it.
Yeah.
Snap it.
That's per meter square.
Smash
which is
through it.
commensurate to energy densities on the order of 10 to the 20.
It's not a gentle little thing.
So, in other words, you can lead to something called
the same idea with
dynamic
snapping the
vacuum
edge
breakdown.
grab flyer.
When you achieve, yes.
I'm so sorry. As an aside for the audience, if you're not following what some of these terms are, don't worry, because as we continue throughout the podcast, I'm going to be stopping Sal at different points to explain certain terms, like even simple terms like what is a piezoelectric material. I know it's piezo, however people.
Piezo. Pizza. Nice,
what
dude.
Is he talking about some horn tweeter? What is he talking about there?
The Schwinger. That Schwinger. So I want to talk some cool stuff because this is stuff I brought up before.
I was surprised to hear you talking about it. I'm like, did he get read into one of the programs? I was wondering where you got that from. I mean, who was it that
Me?
got you all on the boat? Yeah, you. I mean, did you just find it on your own? You just figured out that you can break space time like this on your own, or did somebody tell you?
I found this a year ago. Remember this case?
Yeah, I do. Yes, I do.
And when I started reading Isaac Kemp's, he was doing more classified research apparently for Air Force Research Laboratories out of Wright State. And I was just looking up, NASIC and Wright State stuff and classified. And I stumbled across this story. And I looked into this guy, Isaac Kemp, and, I went and read his PhD thesis, which I downloaded off Wright State University's website. And I started just reading all the thesis, the PhDs, all the thesis and all the papers that he's written and all his colleagues have written who worked with him at the terahertz and ultrafast photonic labs under Jason Diebel at Wright State. So I just started digging into that, and holy crap, I started learning about these squeeze states. And then, going back, when I went back over, I was going back over the Eric Davis stuff. He mentioned the squeeze states right here, right in his work,
That's exactly what I was trying to say before the show started about the angular momentum.
He was talking about this. He's like, well, how do we cover the scheme for creating negative mass and negative energy densities? How do we do this? Because that's what we basically have to do.
All we got to do is remove positive energy from the localized space, and we've got effectively negative energy. It's not that difficult to imagine. You're just removing pressure from the vacuum.
Are squeeze states like closely resonated signals?
Squeeze states are modifications to the refractive index of space-time. They refer to how matter will flow through a volume of space if it already has some, say, momentum and velocity. It will flow at different velocities or different rates through that same space, depending on the total amount of stress energy momentum of the localized space that the matter is passing through. So it's the same thing with charged particles. They don't just experience a squeezed state in terms of their dimensional relationships to each other, but they also experience squeezed states of electric and magnetic fields as they pass through that space.
So it's
Yeah.
There's this thing, you know, the Heisenberg uncertainty principle. You familiar with that? That's this thing on the left here.
Yeah.
R over 2 pi is so your momentum in your exact position, which is this delta x, and your change in our exact momentum is always only knowable to within a degree of h bar over 2 pi.
And that's because space-time is chunky, right? Effectively, when you go down to the fine structure constant, it's chunky.
It's chunky.
And that's why we can't tell the exact position, even though there is an exact position. Like, let's not get it wrong. Quantum mechanics doesn't provide that exact position, but there really is one. It's just that it tends to jump in band gaps through space. You know, it's a very staggered staccato kind of motion.
It's a probability function. Once it gets down below that certain level, it's you're probably here, but you could be here, right? And if you know x, right, if you know exactly where you are, then you don't know your you don't know your momentum. So, so basically, like, if we nail down your position to like a degree that's really, really fine, then your momentum just jumps to infinity, which means like you could also use this if you think about it. If you could localize your position and with these squeeze states, you could jump your momentum really fast.
Yeah, that's the Musha jump drive. It's effectively what it does. It
Yeah,
builds up the stress energy tensor in one direction for a period of time, and then it releases all of its stored energy in a simultaneous burst that cuts through space-time and delivers the craft to a destination that it was already starting to formulate at, where those fields cohere.
Yes.
So it's not that different, really.
Yeah.
So
go ahead.
One thing is cavity resonance, because it's a cavity in which that you're doing this. You're creating this negative energy curvature in space-time. So you need a cavity resonance, and cavities have
magnets will do that.
Well, we got good people on today, man. Look who just joined us. I mean, in the public chat.
Create the cavity that you need.
Oh, dude, get on here, man.
He probably can't right now. If you can, that'd be awesome. But damn, dude, this shit's like, he knows what's up, dude. You were on about it. We were on about it, and it's been interesting because, to say the least, he's been quite on the ball. I don't know where he gets his info from, man, but I swear it's some extra level shit.
Well, he's been on a lot of this stuff, dude. I mean,
Tarek, did you finish your repeat experiment? Did you run that yet?
Half this shit on the drive, dude. Magnetohydrodynamics. So this is obviously, like, Bob Lazar knew something about MHD, because that's what he said. He claimed to have gotten his master's degree from MIT.
Maybe that's what he's covering up with his silly idea of the element 115 and all. So he doesn't keeping with non-disclosure agreement and doesn't get fucked with any further.
Well, he talked about detecting, like,
I have a paper from John Andrews where he wrote to all the leading experts in magnetohydrodynamics back in 1989 and received letters back from all of them, and they say that they had never heard of him and they couldn't find anything in the literature.
Oh, wow.
Well, you know how, hey Jeremy, you know how with surface plasmons you can move around electrical charges and you can create these quote unquote holes in the surface topology of the electric fields for the material, right?
Yeah, Dirac holes, is that what they're called?
Right, that's one of the names for them. They have several names by different scientists throughout the ages.
Yeah.
That's one of them, yeah. So they're considered to be equivalent to positrons, but they're technically not considered to be actual matter. They're just holes in electrical scalar potential caused by the motion of electric charges being stretched out or separated from each other. Well, here's the thing. Under the influence of a magnetic stress energy that was added to the volume of space, so you have a real amps per meter that's equivalent in that space, during which time you are creating these Dirac holes. It allows that virtual charge to separate itself out and become a tangible real charge. So this is where you can take a hole and you can actually turn it into a positron in a real sense. That's what I was looking at, is considering, you know, the small energy requirements, the consequently small energy requirements, because the magnetic torsion tensor and the electric scalar potential tensor don't couple to each other directly. If you have them at a phase angle of 0 degrees, they're technically 90 degrees to each other in their propagation through space-time. So it's one of those strange phenomena where you can build up a local stress energy that drastically exceeds the Schwinger limit.
And
By
then
having
you
these two
use
cross-
all that front force. You're coming at it from out to the other angle.
Right, but you're crossing
Yeah.
fields. So your
Yeah.
particles want to go and follow both of them, but they can't realistically do that. So there's a differential for the force felt by the positively charged virtual particle versus the negatively charged virtual particle, and they're pulled away from each other. That's a physical motion of space around yourself. Again, you're not moving through space like it was said earlier, but you're moving space around you.
Yeah, yeah.
And that's what makes the space, are these virtual
Yeah.
charges and their energy density.
I want to listen to this, and like this is some good. This is some
Play
good
him.
stuff from Freeman. I wanted to play this for all of us and here
let's watch this.
watching, because Freeman Dyson is a genius in himself, and he's saying
Oh,
that
yeah.
he talks about how difficult it was for him to understand Schwinger while working with him. So
I got on the bus in Berkeley, and I always loved these long Greyhound bus rides, especially because I never stopped on the way. I would go. In those days, of course, it was very different from Greyhounds today. They had these long rest stops where you could go to the bathroom and get meals.
Daniel's dog
They didn't
barking
have
right on
bathrooms on the
cue.
bus. And so
The Greyhound.
you could actually see a lot of the country as you went across. You'd have usually half an hour or an hour at the rest stops. So I saw a good deal, and I remember Wyoming, and I remember Salt Lake City, and I remember Kansas. And but anyway, somewhere around Kansas, after about 48 hours of sort of half awake, half sleep, suddenly everything fell into place, and I understood Feynman and Schwinger altogether, how they fitted together. And Feynman was essentially talking the same language as Schwinger, only putting the time in a different order. And so the Feynman propagators were simply time-ordered green functions, and they were also multiple commutators. So all three languages actually were the same.
May I interrupt you? Then this was done without paper. This was really done on the bus.
Yes. Yes, it came absolutely just in my head only, and I knew very well that I couldn't write on the bus.
Yeah.
I knew very well that once I got to Chicago, I could write all this down, and it would make sense. And the equations were sort of already well formed in my head, and so we droned on through Iowa, and finally ended up in Chicago. And there I stayed also in the International House in Chicago. Spent a week there, and walking around the sand on the shore of Lake Michigan. I explained all this to Christopher Longet-Higgins, drawing diagrams in the sand, like in the style of Archimedes, and we had a great time. And so I was able to make it all clear, and then heard of Tominaga. This was the new Japanese, and his techniques were very similar to Schwinger, but much more, actually crystal clear, much clearer than Schwinger. So that helped again. And anyway, so I wrote up the paper.
No one said it was simple, man. You're still muted, Daniel. You gotta unmute yourself first.
Oh, I
There you
have
go.
to do it. What happened to my TV? What happened to what? The TV won't work all of a sudden. Oh, look at it. I better unmute myself again. Hold on.
So is it like a green function, just like a normal distribution, or what? Like Gaussian related? Oh. Okay.
Jeremy, you're muted.
Oh, so these complex vector bundles to describe space-time, spinners. Oh, damn it! Hear any of this? So
Now you got it.
I got to go back
Well,
and talk about.
Yeah,
this.
go back to the people were asking you about the graphs that you showed and what the distribution curve is representing.
So this Green's function, and I don't know how it muted me right when I was talking about Green's functions, but
Must be important.
it turns out that the Green's functions are the same as commutators in quantum field theory.
Oh.
So break it down. What's a commutator?
Like non-commutative functions is like that.
No,
Okay.
no, it's like commutators is a way of it's the same way of generalizing. It's the same, basically the same mathematical treatment. I don't know, some roundabout
Okay.
way. It's
I was reading on something about associative algebra as a way to.
Yeah, you know what I mean?
Yeah. I was reading like something about associative algebra to use on this similarly, but I can't remember for exactly what. They were talking about like time reversal and time crystals.
So this is where it's at now in 2018, where it's approaching is I believe is with this knot theory stuff, because we're learning more about how all these branches of topology and math are all related, because it's all just a network of knots like in space-time and how it connects to itself at the basic world.
Yeah.
Oh.
Well, I had a video on time crystals. Actually, I found that they did. Hold on, I'm gonna try to look up the
agreeing
deal.
be with us or on knotted.
No.
What is
This was great that he had Wolfram had Kaufman on. This was amazing, and it should have way more views than this. But I'm the one that kept going on Wolfram and telling him you got to have Kaufman on, and they finally did. But I learned about Kaufman through Ken Griggs and Phoenix theory, because it's very similar treatment of this quantum field theory and how to look at space-time
paper.
And like he said, it's related to this entanglement thing. That's what Ken always is keeps stressing, is that it's related to that you still have entanglement, even or basically what you're doing when you break this quantum vacuum polarization is you can break entanglement too. And it has to do with these, what, again, back to what, in that one part of the Kurt and interview, right, with Sal Pays, when he gets into all the quantum field theory stuff. So right here, why quantum gravity is so not trivial. So Kurt's detour and answer, right? This is good. Can we play this?
To talk about this,
This is for review and possible criticism. That's right.
The idea of quantum
Fair
gravity
rights use.
and speak on it.
Oh, we're going to be
Because I know
picking
you're
this
quite
apart for
knowledgeable
the
in
next
this
year.
Sure. So how about this will take about 4.5 minutes.
We got to get this
maybe
guy
5.5
on
minutes
Apex
or so.
Dude, I know, right? Come on.
Explanation of why quantum gravity is a particularly tough, formidable subject.
I don't think he'll
outside
go
of
because
it
he
being
doesn't
strewn
seem to
across
want to
many
get into the
lectures
secret sauce.
and certainly never concise
what
and
we're
even
all
precise in a
about.
podcast. So if you don't mind, I can.
Well,
go
he
through-
might not be able to disclose a
So-
secret sauce, but he
and
can
by the
nod
way,
his head when we
why
talk
I
about
say
it.
this is that
And we know
we
what the
have
secret
the
had a
sauce is.
tremendous podcast
It's,
with Professor Carlo
it's a
Rovelli,
translation
right.
between virtual matter and real matter.
hold in great esteem, just like I hold
When
Professor.
we ask the right questions, we can see facial expressions that are telling.
Responded to my emails on the Superforce.
Oh God, you don't
That's
think
another matter.
part two? Like I swear, like
Carlo
Kurt
Rovelli,
couldn't ask him
in
half these
his,
questions because he realized
he
like
spoke of this new book. I think
he's
it
got to
was,
get him by
published in
surprise in
22
part two, like
by
and really like hit him with
Professor
like,
Jacome, it was by
oh wait a
Armas
minute, we
of
might know some
University of
shit about this.
Amsterdam,
Conversations
called
on quantum
Conservation.
gravity.
That is exactly it, sir. And
I'm not hearing it.
Anybody see it?
In classical gravity.
I turned it down. Hey, did anybody see Kurt's April Fool's prank?
No,
No.
not yet.
You haven't seen his April Fool's prank?
No, this I gotta see. Play it.
Oh, dude, I gotta go. We can interrupt this because he gives
Nice.
a great breakdown of the whole, the whole standard model, current standard model physics, and all this topology and group theory stuff. If you guys don't know, group theory is a huge part of the standard model, and it's basically the mathematics that we've reduced.
Cool. I'm more of I'm more of like the the dimensionalist type thing. So it's like you would just use like non-Gaussian type measurements or something to measure all of it.
That picture that you just showed a moment ago, Jeremy, was that an antenna or was that a diagram from group theory?
That was it looked like that fractal antenna.
Dude, that's what I'm saying. I have to see that again. Compare those.
It's called the
Come
Cayley
on.
graph.
Dude, get the hell out of here.
Of rank
I
two.
mean, if this isn't relevant
Definitely,
to
if you
space
printed
diametric
that-
engineering, I don't know what is. Look at that thing. I mean, come
Yeah.
on, that's exactly what he was saying. He was saying, yeah,
Can-
his antennas mess with space time.
2D dimensional, like from the screen, with using fractal operators to
similar
like
to-
somehow couple with 3D.
Yeah,
David,
the
Would
Koch
that-
antenna, the Koch fractal antenna, exactly. It's a 2D planar antenna that couples with the three-dimensional spacetime around it.
Yeah, but can you like on your screen, like can you make the video in some way like
me
create a frequency coupling to like
Got it.
our 3D space?
You should show the Koch fractal antenna compared to that, Jeremy. I'm not sure if you can couple it to through some graphical interface. I mean, it's a technological implementation at that point. Can you actually produce sound and light in virtual space? It's theoretically you can. You have to consider what matter is already there. Like in atmosphere, we have these ionizable gases that can be used for photonic generation through ionization, and that's how those photonically simulated pulse laser systems work. But when it comes down to a more practical, say, home implementation, if you've ever seen the machines they're using to create those pulse laser displays, they're massive machines. They draw 20 kilowatts or more.
So I can immediately spot some difference.
Yeah, come on. I mean, if this isn't related, Jeremy, really.
Well, I have a thing from something about the physics of fractal operators. So this one deal, but I have to take a look at it. I posted a link in the chat I think it was a private chat by Nader Ngita, Wave Interaction 4D Metamaterials. If you type that in YouTube search bar, you'll find a video about him talking about time reversal crystals. Or time reversal in crystals, like certain math formula or something. It's kind of interesting.
What's interesting about these is the symmetries because of how they fold in subdimensional space. It's ways of linking things up, and it relates to a lot of physics. A lot of the physics that goes on is all what's called fast Fourier analysis and Fourier series, right? Have you ever seen this video? It's explained graphically. Oh yeah, this is brilliant. This will blow your.
Let me explain
freaking
what's
mind.
happening here. Amongst academics, there's this thing that I just now made up called math swagger, and basically it's like math, they like think they can do anything with it. It's not like a
no. So
Math swagger.
a
Nice.
multiple simple harmonic of wave is a square wave, but the difference is you have sharp edges in a square wave. The
I love
first
that
thing
online app.
to impress me is he used curvy waves to make sharp edged square waves. We have to add up different oscillations or simple harmonic motion here.
Harmonics, yes.
Yeah, and so the first harmonic, n equals 1, gives you this,
Yes.
which looks nothing like it.
Not interesting, just boring sine wave. And I add one more. It's actually like it. I'm adding one harmonic and other one third of that harmonic radius.
So you're adding a base. What are we going to call these? Wipers?
Yeah, let's call them wipers.
Okay, so we're going to add a wiper on a wiper, and by doing that, and we graph the function.
And then follow the tip of this wiper.
The ascending ancient is on it. There is a hydraulic analogy of space-time which applies to what we're looking at now.
Really, really beautiful and really, really simple.
yeah,
So
it's
I heard there's more than using, but there's even other ways besides Fourier analysis to like monitor
Oh wow, it
the
looks cool.
signaling pulses and stuff.
So you're saying, so basically, here's the upshot. A Fourier series, you can create any function as a function.
Mostly they're all like what
in addition
convergent series,
harmonic motion,
like Taylor series and
right? Yes. All
all
done
like that one guy was talking
these
about.
sine waves that we explained earlier, and he's stacking one.
But
on
yeah,
another,
Fourier series is pretty cool.
stacking the circles, add together these waves to create a
square
Fourier
wave
series. These visualization techniques,
And that's exactly what we see on the scope. Even when we try to generate a square wave directly, we see those front edge spikes. You see how those spikes are always there? They're an electronic analog for the hydraulic current of electrons accelerating through and being in motion within a conductor. Their electric field around the conductor has to fall back in and neutralize out against the local space-time metrics. And it doesn't do so in a linear way. It does so in a first parabolic and eventually reaching hyperbolic way. And that's why we get that spike on the front edge of every electrical impulse. It naturally
and that's
forms
why
itself.
you need that leading edge. It's like, and it's in all these experiments. It's like you need that
super fast rise time, leading edge, very sharp.
And what that does, right? So that what you're having here, right? In order to generate that, if you think about it, right, is you're taking this and you're making a super whip, and then you're whipping the tail end of it so that it goes super, super fast. Because that's what happens at that to get that really fast rise time, you got to get that you got to build a whip. That's why it looks like a whip.
The analogy of the whip is a really good one because you're taking a low frequency motion, you're whipping it like this, and at the end, that waveform is shrinking down and down and down and down, just like a wavefront coming up on the shorelines where you have a tapered ascending front, and and you've got this wave coming up, and you get the tidal wave, rising up as your thickness of water currently present changes, and it's the same whip action. It is a perfect analogy. That's what you're doing with electrical inertia. You're whipping it. You're getting charges to move through physical space. They create a compression wave like a Doppler shift around the front edge. It looks basically, if you visualize it with computer graphics, it looks just like a bow shock on a super sound barrier breaking plane or some forward facing projectile. It creates
That's
this bow shock
exactly
in
what
front
I
of it.
meant about snapping the magnetic edge band of the graviflyer.
Look at this whip.
Where they snap on a wavefront as they're turning.
So you build up this whip electronically. It's basically the same thing you're doing, and you're when that whip hits supersonic, it's not supersonic. It's super Schwinger.
Yeah, with the electromotive force, it's superluminal.
Yeah, superluminal, or super Schwinger force. It breaks that space-time barrier, and you can get that nonlinearity.
Yeah, it contains more than 512 kiloelectron volts, and in that degree of localized stress energy, space-time falls apart.
I wonder if there's a way to like numerically
build this with. They build
produce
this any picture with on a 3-axis, so they got a 3-axis drawing model. Interesting how they do this. But,
That is pretty fascinating, isn't it?
To
Just
get-
with a series of tied together sprockets, you can create just about any shape and geometry repeating. That is pretty interesting.
Like I said, that one guy showed you that Interbin guy from MIT has some information on with the nano brain gel stuff he's been doing. Like I said, he used fractals to try to model vibrations and stuff, all different types of signaling. So I forget what he was saying, that certain signalings couldn't be detected with standard Fourier series, but that's in his book, so you would have to get that.
Yeah, this was video by Smarter Every Day. Dude, thank you so much for your videos. These are awesome. Please watch my videos and maybe you'll get smarter, learn about some of the space-time bending stuff and the Schwinger limit and do a video on it. That'd be awesome to get some more attention to this. Please don't copyright strike this. It's for educational purposes only. Guys, we're having an open call-in talking about some of the classified stuff that's been just flowing out across the internet. Anyone who wants to look, the information's free, man. It's like, who wants to learn? And it's I figured it's such a complicated nature. It's more about the education and the science than about anything else. And we're all moving forward as humanity because this technology that's coming out is going to unify all of humanity and bring us off planet and bring us to space. And we're not going to need oil anymore. We're not going to need to fight any of these stupid wars that are going on.
No more slavery.
Won't be any of this, man. And this is what we all need to work forward and work towards as a species and as a collective. And I'm grateful for people like Kurt. Man, Kurt is the man. He's bringing all these great. How does he get these interviews, man? Sal Pays he said something about it in this interview. He said like he thinks Kurt is like his brother and his soul brother because he gets it. And I understand that, man. I'm more I would love to have a conversation with Sal and understand why he thinks like who the good guys are, because that was who are the good guys, man? This guy's like, oh, I'm gonna keep this classified because I don't, I think it should belong to the Navy, and that's why I filed these patents with the Navy, and I wanted to give them access to this, so when it does come out and they have it, and that was his story. Do you guys believe that? I mean, what is he's an awesome interviewer, man, like he does such a good job. It's and I can't even keep a schedule. I fucked up with Stephen Cambion tonight, so who am I to say like, oh, I want to get these interviews, man? Like, honestly, I'm sorry, Steve, man. That sucks. But yeah, Pays knew Kurt would validate his theory or hypothesis. That's one theory. What do you think? We're about an hour in. Oh, let me see. We got some.
I gotta hang up, fellas. My phone's just about to die, and I don't really have a long enough cord to stay on with you.
Daniel, thanks for joining us. I'm gonna try and rotate you out. We got some. I just noticed we got some other people waiting backstage. I wasn't even
okay.
We have how many people waiting backstage? Hey Dan, man, thanks for stopping in. I wouldn't have gone on the stream if I didn't see you in there, but I had to stop by and say hi. I'm glad to see that you're on the stream too. And talking about this. I missed everything you said before I came on. Just so you know, I didn't hear any of what you said before I came on, so I'll have to watch it later.
We're bringing some chicks to the party.
All right, maybe I can catch you later on in the stream. After an hour or so.
Yeah, you can just give me a call too later after the show if you want.
Okay.
Hey,
when you see me log off,
type this in the YouTube bar.
Goodbye.
All right, Daniel.
I left out some of the secret sauce.
So type this in the YouTube bar, or unless you're still looking up stuff.
I left out some of the secret sauce.
Oh, the secret sauce. What do you guys think, huh?
We don't tell him how to make positrons. Don't talk about positron.
Some positrons going on. Is this what we're doing? Arrow. Oh my God. What's up, dude?
Hello. I've been listening. Great conversation. It's awesome.
Yes. So, you got any classified technology to drop on us tonight?
No, I don't. Except I'm making food, and it's
Damn it! Everything's declassified. That whole declassify everything. It's not even cool anymore. It's just like, yeah.
Although I don't necessarily see a problem with giving things to the Navy. I mean, if this technology is legit, if what Payas is working
Yeah,
on.
I know, right? It's
Who else
not
would give
really
it to?
that bad of an idea. I don't really, I don't got beef with the Navy or the Air Force or any of these guys with directed energy weapons or any of this crazy stuff. Please don't use that on me. Let's work together. Let's work together and try to use our genius. And I'm already shadow banned to hell, so
right.
I'm probably banned in all these other countries anyway. If you guys know what you're doing.
I kind of wonder if you're shadow banned because it's like a friendly thing. They want to keep you secret.
You know what? Yeah, right.
Which doesn't help you, but
next UFO road trip,
Right,
I'm gonna fly to St. Petersburg, and we're gonna try to look up AlienScientist on a random computer there and see if it is blocked.
Well, I always wonder if they're waiting to release more of this, if they're starting to drip more aggressively because they're waiting on certain potential bad actors like Putin and other. And I know that's a whole complicated thing, but I wonder if it's just people behind the scenes are nervous about whatever the current political situation is. But it's never going to be perfect.
Ooh.
So it's gotta.
Well, if this is true, then the Russians had this shit in '65.
Sure. But could they actually make it, or was it all just bits and pieces? Maybe
I'm liking this diagram. This is nice.
Purging pulse and the propulsion pulse. So I'm sure they there's other pieces left out. I'm sure.
It's starting to look a lot like Smart Skin, isn't it? Smart Skin.
Yeah,
on the
it is.
graph.
But the pulse. Electric aerospace propulsion system. Wow.
I mean, we have all the stuff and all of this information. Why can't we just make it and fly?
Well, we are trying to make it. That's the entire thing. Is us garage experimenters out there, those of us who are not super academic and have this whole idea that we might be able to build it with these grubby little 5-digit appendages that we have. Yeah, we're doing our best to try and put things together that actually work and show demonstratable.
We got other people on the team with 3D printers and other technologies too that are I got a guy. We're gonna take that David Perez fractal antenna stuff and bring it to a next level with what we're gonna be able to print on.
Too late, already did.
How did that work out, dude?
Scary.
Wouldn't it be like the future that we could print people? I mean, down to the.
Yeah, we have talked about that. That's actually a
Yeah, well,
conversation that we've had in private many times.
I mean,
about printing biological materials.
Imagine that. It's like I know some people with I know a guy who only has one arm, and imagine printing him a new arm.
I've seen stuff like not printing, but like prosthetics that have like sensories on the end where, like with mine, that they could actually move, without it being plugged to anything, or you just. I've seen those, and it's pretty cool. I mean, like to be able
it's
to control
electrical epidermal stimulation via sensors. It's very much like an advanced EEG. It has a preamplifier and a post-amplifier. It detects tiny electrical impulses on the surface of the skin that's left over after the amputation has occurred. And those electrical impulses are still present, so they're able to control other external appendages with the correct signal amplification. It takes a very high degree of noise filtering, but otherwise, like once a person gets trained in how to use and interface with that system, it can work pretty well. It's not ultimately what we want, though. What we're talking about here is going to step beyond an augmented robotic appendage. We're talking about actually regrowing biological tissue with this type of technology.
So it's just connective firings, right? Basically, from the nerve endings.
Well, how does the body know what to do? I mean, how does it know what tissues to grow and how many times can a cell split? It's about 5 actually before it starts to become cancer.
Well, the cells resonate, so like they would definitely communicate if they're on the same resonant level. I wonder if like you could somehow have like a dislocated arm, like a disconnected arm. Like, so you have a arm that's severed and it's like 10 feet away from you, but say your stub, that your arm is a stub and it's got like like it's missing half your arm, right? And then like somehow the nerve endings are an empty space away from it, that somehow maybe just the firing itself of the nerve endings can somehow still reach the severed arm. You could still move it.
I think what you're talking about is coherent nervous system signals. And NASA, there's an old piece of folklore. I mean, I can't prove that this is factual. I tried to find papers on it and couldn't. But there's an old piece of folklore that NASA took the earliest of astronauts, human beings that they sent into space, and kept skin and blood and tissue samples on Earth to test during the time where the astronauts were in space, and asked them to specifically stimulate certain parts of their body with the equipment they had on board in order to see if the Earth-bound biological material that was being kept alive in the lab would respond non-locally to the signal simulation of the human being that was in space. And from what I've been passed down to, what's been passed down to me, that apparently these signals do translate directly and faster than light back to the biological tissues that were kept on Earth. So again, I don't know if there's anything to this, but if anybody has information on it, I would love to find out more because I have.
It sounds like virtual. It sounds like gamma ray type, because gamma rays are faster than light, right?
Sounds like quantum.
Not normally considered. Gamma rays aren't normally considered to be superluminal.
Or what was that, Arrow?
Conventional physics, at least.
I said it sounds like quantum consciousness. It sounds like, evidence for that whole thing.
That's what it sounds like, yeah. The real question would be, is there a way to somehow objectively prove this instead of just the speculation and the dark projects that we can't get our hands on the information for?
Like DNA entanglement, like it signals each other. And so,
you see all this stuff on my screen about all the sensitivity to all these biological processes that involve voltages and so they can
everything from electrosensitivity to biophoton emission and reception. I mean, the rabbit hole is deep on this subject.
Ligand gated neurotransmitters, lipid gated ion channels, and all
the
these
sensitivity is insane, dude. I mean, how many times have people closed their eyes and said they see these little flashes of light within their cone of vision? It's a strange phenomenon, but some people are extremely receptive neurologically to different inputs and stimulations.
But also seems like the human neurology, like the brain, is pretty hardwired against a lot of external interference. I mean, there was a lot of research that was done into beaming mind control and stuff inside the mind, but like I really couldn't. There's really not like any kind of crazy smoking gun like, oh wow, there's a definite research that you can make people, you can control people with it's not as, it's much easier to control the mind. I think they gave up on a lot of the electronic research and they realized that mind control is way easier through Kim Kardashian and this bullshit freaking cell phone that we can put in people's hands.
Direct observation is going to allow the observer or the victim to believe they came up with all the ideas completely on their own and that they're the normal state of being or thinking. Having no other external frame of reference, they're not going to know better. So why would they not assume that the world is exactly the way that they've been told it is?
Unless they detach from the world bit by bit and
see it for what it really is. Yeah. Yep, exactly. You have to step away before the picture becomes clear.
I mean, we're talking everything that's digital signatures of existence.
Well, what's really interesting is those sensory deprivation chambers. You start losing all feel of stuff, where There's no light. There's no water. Like, you're just floating. There's, like, no touch and no sound. So after like the 3-hour maximum mark is when you start to reach the hallucinogenic stage, and you start to have some really tripped out experiences, they say, which is kind
Isn't
of
that wild?
interesting.
You know, the brain will automatically start producing extra amounts of Dimitri upon the opportunity to no longer have to process and discern sensory inputs.
Yeah, and like the brain is able to like create its own entertainment, so to speak, or whatever it's and that data itself would be interesting to collect. And so what would it all mean as far as, like, I guess a hologram interpretation of the brain's wave nodes, would probably provide an answer to what, whatever's processing at that time.
Bento gets it. He knows what we're talking about.
Have any of you ever had a near-death experience?
I never have personally, but I know some guys that said they might have, but that's only hearsay, based on
Or
testimonies.
get electrocuted.
I've had that plenty of times.
Okay.
I would just say the confluence of Kim Kardashian and alien propaganda is Kim Kardashian. If you've ever seen that meme, it's Star Trek Kardashians. Okay.
All right, guys, we're doing this for brain, and it's a study that we've been doing on all these live streams. So the winner is going to get some money here, and guess a number between 1 and 100. Right now, I'm gonna roll
15.
95.
I'm gonna guess 36.
99.999999999. There you go.
You should really try to choose a number that can possibly exist in 2 dice.
I'm gonna do like 75.
I said 95. So.
I'm not gonna guess.
All right, we're gonna see who's got the precognition roll.
What's the number? Oh, 30. I was off by 2.
What is it?
38.
Nah, I was off.
Dang it! I was off by 2. Oh.
Oh well.
If you invert Jedi's digits, you got it.
My mind was thinking a different number, but I like this.
So John Doe had 35. Taryn had 27. Pretty close too. Oh,
I had 36.
Ramanuskis. Ramanujan. He was at 33. I think he was the closest, man. Yeah.
Hey, Jedi, whatever number you predict next time, flip your first and second number and then post
You
that.
win, dude. You win, dude. Where'd you go, man? Here's the. Did you forget the link? You win a lifetime supply of Tic Tacs. The breath mints, not the.
You mean not yet?
Not yet.
I've got a lot of documents on my phone.
The refreshing, levitating mint that reaches its way straight to your taste
But
bud.
it could like open up a whole new like area in science, or at least link it, all together. I should have when I went to New Jersey, I should have like asked one of you guys, like, hey, there's really cool stuff in here. How do I get it? Like, how do I put it out in the world? Like, how, with this, or how do I link it all together? But I've got really cool stuff,
Some of it just takes time, because it's like you got to build up a lot of the basic knowledge and other stuff, and then it's a lot of these are concepts that you have this idea of that, but then you need like to know what else it's called, and then you find out, oh well, it's not just called this, it's called this and this and this and this, and all these other scientists and
well, I think it writes itself according to us, and so the new science unveils itself according to It's analysis of the human. You understand? So whatever you see in the time, all this, it's like generational. It's meant for at this time, with on this time, it's gonna appear into whatever, science knowledge base for humans. So I mean, that would be the evolutionary rate, regardless of however whatever time could be. But this segment of, gene pool would be the timeline, and it would be, and so, as we progress, new things will come, but within, like that time. So you have to take into accord science, and down to the things you can't control it, no matter how many things you build, no matter how many, thing at the end, on a bigger magnitude scale, it resonates. So yeah, maybe it can be controlled like a little bit, but then you can't. Nobody can.
Well, I still think that I get what you're saying. I think we're still at such a primitive point that we have to either have drive or we just die. We're still at that point. We're not at a point where we can have stability.
Who's muted? Oh, hey man, there's some things you can joke about, and I don't know why some.
I truly believe that, existence in the speed of light or beyond the speed of light has occurred. We're just living the colored world version of it. I saw this thing that, like, imagine an X-ray world. Like, there's two different worlds, like this and that, and then you've got the different variations and the, of mergers of the different colors to create everything. But it starts, in one world first, like, or white world, and then black, and then X-ray, and then you've got the the MRIs, like now the pixels, the different densities of matter that that first thing is, and then we end up with our color spectrum of time, and that is whatever we see as human beings, and it's just like like so small compared to the whole frequency range.
Yeah, man. Hey, we got the winner on here. He guessed 33, and it ended up being 30.
I know,
8.
but I just like it's difficult to put it in words and like find like this. I like, it just makes sense. Like, you learn something and then it just grows. And I think that's what evolutionary rate is. It has to match up with time, and that's why our systems always are off from from my streaming to device to how much power I've got on my battery. So how much.
All right, so I want to play this. This looks cool. About this is the channel 3 blue, 1 brown.
This right here is what we're going to build to this video. A certain animated approach to thinking about a super important idea from math, the Fourier transform. For anyone unfamiliar with what that is, my #1 goal here is just for the video to be an introduction to that topic. But even for those of you who are already familiar with it, I still think that there's something fun and enriching about seeing what all of its components actually look like.
Oh, yeah.
The central example to start is going to be the classic one, decomposing frequencies from sound. But after that, I also really want to show a glimpse of how this idea extends well beyond sound and frequency into many seemingly disparate areas of math and even physics. Really, it is crazy just...
So by the way, I want to kind of do a study like this on our own with that Chichen Itza pyramid. We could take the recording of that clap, find the incident wave, run it through Fourier transform, then the reflected wave, run that through Fourier transform, and then do our own study on this. Because remember I said that Chichen
another great example of the Bragg pyramid. You should play this video if the audio will come through all right. It's of the red pyramid. Check out the Bragg reflector inside of the red pyramid. They don't label it that. It's just called an acoustic resonator chamber.
Yeah, so for those who aren't aware, a Bragg reflector is a term in
Well,
physics.
the old scientist channel was doing tests on pyramids. And he just
So-
made miniature scale pyramids, and like he started stacking them and getting these weird effects of frequency rises and
Oh yeah, look at that.
timings.
Is that not a Bragg reflector or what? I mean, is how much more obvious
a
could you make
Bragg.
it? 13 layers in one of them. And when you all you have to do is sing one specific tone into that chamber, and it will produce 7 harmonics, 4 of which
What
are
if it
highly
starts
audible.
moving the stone and or more frequencies that it
Well,
becomes?
here's a
Yeah.
thought. What
Yeah,
if
but
you?
also like I just think from an engineering standpoint, that's a good way to build like the roof.
Well, you know how there's a video you showed of the guy clapping? There's also a video of a dude singing inside this thing, creating a single tone, and also one of a guy with a synthesizer in there. I think Brian Forrester had recorded and documented that with a tour guide that knew how the Bragg reflector worked and was able to sing to it. But anyway,
I love
the
Brian
chorus
Forrester.
being
That is
produced.
so
You can
cool.
pull the video and play it for everyone.
Oh, I got
It's
an
pretty
idea
awesome.
for you,
I'd
Jeremy.
love to see it, yeah.
You could try to make a pyramid hat. If this thing's like an acoustic, amplifier of a sort, I wonder what a tiny hat pyramid would be on someone's your head, like on the head, would actually do.
What a
I mean,
video!
that's just
You just do the wave traces. So this is what it looks like all the way up. Wow, that's brilliant. Look at that.
I think there is like a church in
sounds as
Europe
good as it looks.
somewhere. There's like a church in Europe somewhere, so it's built like in certain way, so you can whisper in one corner and somebody can hear in another corner.
Yeah, I've heard about that. Like from like old castles, they do that on purpose. Like they, so whatever the king, the queen can stand in one spot and hear everybody's conversation. Yeah, it's cool.
Yeah, that's interesting.
I'm trying to find it now, Jeremy. I'll see if I can pop a link in the private chat if you don't find the video.
Yes.
I think this is it. Yeah, Red Pyramid of Egypt acoustic resonance testing, I believe is what it's called.
That distributed Bragg reflector. So a lot of these chambers are built this way. I don't know if it's an engineering design that was done on accident, and then they discovered this as a result of it.
There was nothing accidental about it. That I can assure you. Nothing accidental at all.
What do you think they were signaling? What do you think they were signaling? Like, what did they want
Not
to connect?
signaling, concentrating. They were able to use their own voices and their own instruments to produce very strong nodes and antinodes of harmonic oscillations. What they were doing with it is a different question. But they were able to use it for their own purposes on a personal level as well, and a lot of it had to do with the development of the society and different psychological states.
Each spherical wave is cut in half to make a more smaller wave. So like when it goes up the steps.
Do you think these energies can revitalize like human cells, or not human cells, everything? Like, would it, like, as if
I think it's a
creating
precursor. I have an opinion on it. I think it's a precursor to that kind of technology, like early alchemy was a precursor to chemistry and so on. I mean, I think that it's in that direction. I'm sure Jeremiah knows all about it, but
it's like sending a wave two ways, same wave two ways, and then the energy to concentrate it, like forward. So that's the beam that they go through.
It's like a laser. You concentrate photons in one place. It's like with sound waves.
Those pyramids, the Costa Rica megalith spheres are like the resonators as well, just like the pyramids.
Wouldn't there like, what would think like this? What is going to capture that energy? And that's how they connected, I believe, to whatever, other planet. I don't know. But they concentrated their energy. And they harnessed it, because the surface of the pyramid was like some shiny white stuff that reflected the sun. And they said, it could be seen from way high above, like as a shining thing, even in the middle of the day from the cosmos. So they purposely, made it as a reflector from one, from the outside, but from that, exact moment, time, and trajectory in this, there was, that light that went through. So to show, like, with all the complexity, still the human energy still, was able to, one band of probably the fastest band of connection. Like how, imagine if we're sending a bit from one place to another. Well, it's like that for them. Like they filtered out all of the noise and it just, to that one place, all the energy on Earth, all the magnetic, all the, flux, all that, to make that one, energy connection. I mean, it has to make sense. That's the only way that, I would see how some, we could send a signal so strong built with just geometric shapes, and like how they did.
And that's the thing. The pyramids, they incomplete. They're not the same as before.
Yeah, but they like, if we were to build this today, we would have, like, nuts and bolts and this, but this is like natural products, stones and straws, mud, like they didn't have these metals that we do now to integrate. This was just precision stone, like just, like that. I think about it. I mean, that's pretty amazing, to align it like that and to make that, yeah, I believe they were
If you think that
extraterrestrial.
the stonework is amazing, what will really blow your mind is how the stones were made. Remember that the stones in the Great Pyramids at Giza Plateau were quarried from a mine 500 miles away, and the fastest transport to that location was down the Nile River, which was a lot closer to the Great Pyramids at that time. So consider how they made the stones.
Talking about. So there was different types of stone. There's the block, which was from a quarry right nearby. Actually, it was built on a quarry. From most of the block is from that quarry.
Most of it, yes, but there are certain layers of the dielectric outside husk of the pyramid that are not coherent with
so
that.
the
If you take a look at the
stones are
metallurgy, they
different.
contain other things.
So they built it on somebody else's
away.
civilization.
And then all these
not quite,
interior
no.
stones are diorite, and they were brought in from far away too.
The point is that the pyramids are
the
made of
weird-
multiple types of stones, Noel. That they're made of multiple types of different stone construction
Yeah.
and different chemistry, and they were layered in a specific manner that's extremely intentional in order to give them electrical and dynamic properties.
You see this?
Yeah, absolutely. It could be the case. I'm partial to the idea that maybe not in the Great Pyramid, but elsewhere, pouring these blocks was used. Maybe at, other places. I don't know. But the Romans, they had cement that they could pour into the water, and it would set underwater, which is amazing.
Yeah, and think about what the Romans used. They used carbon-heavy volcanic ash in their cement, which made it significantly stronger than modern-day concrete.
Just amazing, really.
Right, and so if you take a look at the Aswan granite, which is prevalent on the construction of the pyramids, what we'll find is that it contains traces of graphene, which is particularly interesting because graphene has a nanoresonant property acting like a miniature antenna. So imagine that you could put radio energy into a stone. Do you think you might be able to affect, say, its space-time metrics?
My gosh, that would be so cool. Like all the stones connect. Like that would be like, the energy from one to one to one to one to one, like little magnets.
Yeah, you got it. It is a coherent resonance between multiple structures.
That's so cool.
That's what I thought too, dude. When I first heard about that and I understood that there was carbon in the Aswan granite, I'm like, holy man, this is really something else.
Science is fun. You start to understand things in a different way. I swear to
acoustic experiments with these types of rooms and these shapes of cavities and stuff, and see what we can come up with, man. This is pretty fascinating.
So I dropped a link in the private chat of people toning inside the Red Pyramid, and you can hear how one tone becomes multiple tones. It sounds like an entire choir, but there's not an entire choir perfectly resonating with each other. You'll be able to hear how
we awaken like old people, like old things, like we don't, like with that kind of energy. Because remember, everything is alive one way or another.
Ballback. That's what I was blanking on. Ballback, the giant pillar, the giant unfinished
My
column.
gosh. Lulu, call me Lulu, please. I don't like no. It's just like this is legal name, for this stuff. You have to put your legal name. I don't like hiding behind fake, my real name. But I like to. My name's Lulu. I like to be called Lulu. Just so yeah. Yeah, what you had was what I was talking the way from both ends.
What about crystals? Crystals are also a rock, Maybe rock can produce some sort of energy too. Maybe.
Yeah, if you get the patterns right enough and small enough, you can store light and much more in these crystals.
I've
But
seen this video.
you would have to be careful because it will start pinning space. And you don't really want to get your anything close to that. Depending on the field, I guess how wide it'd be.
The original line. When you
So-
scale
Yeah,
down that line by 1/2,
I've seen those.
the mass is also scaled down by 1/2, which you can viscerally see because it takes 2 copies of that smaller one to form the whole.
Yeah, and the other half is the
When you
uncertainty
scale down a
principle.
square by 1/2, its mass is scaled down by
Yeah,
1/2.
I was studying about fractals. They're
It's-
not self-similar at a certain limit. They do tend to branch off very weirdly. So there was a error
I was
in trying to use
experimenting.
them as a detection scheme for modulations in motion, But that it's basically a power law series. That's all it is fractals. But the fact that you can find them in some things is very fascinating. The conch shell is interesting. It's a big, just a spiraling deal, and it's not necessarily. Is a conch shell a fractal, Jeremy? Like the lobster crab comes out of it. That's not a fractal, is it? Or fractal patterning? I don't think.
I was playing with it mind games when I watched that video. I was trying to see
Yeah,
if
I
it's
don't
gonna
think
guess my
everything can be
mind where I'm
fractals.
gonna look, and if it's gonna go on that focus.
Yeah, I don't
watched the
know.
video.
I think we're putting too much emphasis on fractals myself as a model for everything. A lot of things seem to be tailored towards that, but I think we shouldn't give it that much credit though. If things tend to steer off on inaccuracies, later down a more wide scale, non-local type, thing. So,
But is
I
it
mean,
not what
they do have
research and
potentials, but
exploration is?
like I said, it's just a power law. An exponent, type deal. So.
All right, man. Well, it's about an hour and a half in. I don't want to keep going. This is getting kind of like far out, and I had
Well,
a
let's
good
get to the
time.
meat and potatoes then, man. Get into the good stuff.
Yeah, anyone got any more classified stuff? I wanted to call in. People calling with classified shit to talk about, and
Yes, no more woo. As much as I love it, let's keep the woo off.
I agree. It's time to lock it down and get some tangible science up in here.
yeah. Otherwise, I'm gonna go to bed, and I'm tired.
Oh man, not before some tangible science. Leave it on a good note. Leave it with something that people can test.
All right. Let's do.
Well, if you increase the firing of ATP to ADP transfers in cells and stuff, then that would restore a lot of previous combination components of chemicals to newer chemicals that were needed from the previous combinations. In the form that like serotonin produces anti I forget. Dang it. It's in LSD drugs, but your brain naturally produces that, so that's requiring better faster learning and things.
What is that? kind of looks homemade. Now I've seen this one. I've seen this one for real.
What the hell is this crap?
Are you looking at Romanovsky stuff? Yeah, you are. That's some interesting stuff there.
Oh, they're
Schomburg
pulsing.
Designs, yeah, he was onto it. He understood particle separation and recombination. I love the music too, his choice of music. Unfortunately, you know, your second-hand audio on there. But Stronger.
I don't get it.
Okay, you're looking at a charged particle accelerator with that system. You have individual segmented cores. In the diagram, he doesn't show it in this part of the breakdown, but those are electromagnetic solenoids. Each of them is wound, and they produce a rotating magnetic field around the central core, which acts very much like a tokamak. Charged particles that enter that space around there are cohered within the electrical structure of the pulsing fields and get torqued around the inside radius. It produces a virtual magnetic field that the whole thing can pull up against. And I do believe it has to do with, again, separating virtual charges via positronium reduction. So I don't know for sure if I can prove that or not yet, but I'm certainly trying my best.
Nice. Is there any testing of this shit? What is this?
He hasn't really posted much in terms of testing or nothing.
That just looks cool. These are cool interviews. All right, cool. Oh, look at that.
Well, what material would that structure be made out of?
Yeah, those
The
are
the
non-silicon
tokamak, the tokamak, the ITRA.
The ITAR. Look at this. Look at this guy burn himself with this.
I think ITRA, ITH. All right, it's the tokamak. They're building it like pieces and.
Basically, it's a rotating charge separator.
It's like the discs on the round thing look like if you look at it, like if you like slice it, it would look like D's, little D's, you know, metal D's, all you know, from that side. I saw how they were building it, like a video. I saw a video of how they were building it.
Well, we know this guy. We know the guy who designed this. So, I mean, it's an interesting kind of inspiration that came out of nowhere. One guy is responsible for all the things that you're seeing on the screen right now.
So who's the guy?
Romanovsky. I think I'm saying his name right. Sean would be able to say.
Interesting. The hell?
Hey, look at the shape of the field, though. Just look at the geometry of the field.
We got to get some plasmas and start messing around.
I have been messing with this stuff, man. I should log on with my phone onto your stream and share some photos. I have a feeling it's not going to let me do it too easily, though.
Right. No, we'll prepare something when we're ready to present it. I want to come to your lab.
Nikola Romansky. I've been saying it wrong. Romansky, not Romanowski. Okay. So Nikola Romansky.
But I think the first time I've heard that too. But
This guy
maybe-
is really onto something. He's like seen craft in the air, and he got some kind of, I think, non-local download from that experience, and was able to create these diagrams from his understanding of what he's seen in those incidents and with crop circles. So he's onto something here. This is pretty interesting stuff.
Question: what if we had like a really, really cool like laser that we timed it, for that beam, like it with a mirror? Couldn't we draw a crop circle, anywhere we wanted on latitude and longitude? Just think about it. Like,
You need a force vector to produce bending and
no, not
electron
bending.
dismantling on the stems. So.
Laser light. Okay.
Yeah, but laser light's not going to do it alone. You need laser light and electric and magnetic torsion tensor fields. You have to have
whatever you want. But just the whole idea. Would it be possible to do it?
Yeah, but here's the funny irony of it being possible. Yes, it's possible to bend stems. Do you need laser light? Well, that's the irony. You don't. Laser light's
Whatever you want to use. But could we possibly at the end beam something to that wherever area and draw a crop circle? Do we have that capability?
I don't see why not. If you can tear electrons out of the stems of plants at a certain point along their length, there is no reason why you can't decohere the matter structure and have it not suffer catastrophic damage, depending on the percentage of electrons that you actually leave within the lattice of the material itself. So that being in mind, you already have an electron depletion source, that being the ionization from the upper atmosphere coming down at 400 megawatts continuously. So,
and another quick note, I've heard, I don't know if this is true, that England has a lot more clay in the soil, and 90% or whatever of crop circles occur there. That's all.
I've heard that too. Yeah, it's a very interesting phenomenon. If we
let's pick a place where we have visual cameras. Like you've got the International Space Station has a camera that's beamed on Earth.
Yep, and you can watch it live being as something interesting happens on the surface of Earth, depending where they are. You can watch the video stream being cut live right in front of you, and then watch it go out for 25 minutes until it finally comes back on and the interesting stuff has ended. So yeah, you can watch the live stream straight from the ISS anytime, and you can also watch how it's systematically disconnected and then reconnected after periods of time where there are things in the sky that they don't want on cam. So yeah, go ahead. It's right there in front of all of us.
Okay, it's not about having it last, but just for us, like proving it, is our technology capable of doing that? Okay, I don't care if it people erase it or systems or and it goes off, but if we could really prove it at that moment that this is happening, we could do that. There is a capability, and that's the important part. Could be done.
Well, I completely agree with the idea that we need to prove it and that we should focus on technologies and ways that we might be able to actually do that to achieve what seems to be impossible, which is proving a conspiracy true.
Not a conspiracy.
It is a conspiracy as of now. I mean, admit what it is. You got a genre correctly. It is a conspiracy as of now because we don't have significant amounts of supporting evidence that are what I would call demonstrable in the proper use of the term. The evidence right now that currently exists in support of the existence of these programs is fairly weak and unfortunately is not damning. If we really wanted to get something functionally done in any kind of political fashion or anything that was going to have a significant impact, there would be damning evidence supporting that speculation. And that's what makes it a conspiracy as of now, is because it's lacking that aspect. So it's fun. I mean,
you're giving me like, oh, you have a boss that you have to watch out for.
Not a boss. No. What I'm saying is Jeremy's audience is pretty much composed of like conspiracy theorists and
politics,
anarchists.
Doesn't see borders, sees it in a scientific, way, and that's it. So I don't care about like all of whatever whoever is doing whatever.
No,
Like,
we got a lot of crazy theories on, but science, like as Feynman said, it's imagination in a straitjacket.
yeah, then we're always going to be backwards, and we're always going to be
The question is,
having
how much can you
divisions.
ride the line of intellectual insanity and technological prowess, and sway your way between what's accepted science and what's totally cutting edge before actually going over the edge and losing yourself in the research? That's
Exactly.
always been the big question.
Yeah, I think it's great to read science fiction and conspiracies and all of these things as inspiration. Art is always inspiring new ideas, but when it actually comes to finding out the physical mechanisms, you got to stay focused on that, you know?
Well, let's take a look at what we looked at today, right? We took a look at
how about this? I'll leave you guys to
Patel
worry,
Energy.
and then I'll keep imagining, because we beam in energy as beings that makes the universe. So yeah, you could create metric systems, but human energy supersedes all of that. You understand? Like, again,
That's what I'm trying to.
we
That's what I'm trying to
create
get you to
what
see now. That's
All
what I'm trying to get you to see, is that it doesn't exceed that. Technology can actually supersede the strength and veracity of those fields that are produced biologically by the human entity. And through that technology, the human entity can connect with something that's on a far deeper spectrum, where we're talking, dimension splitting and the total modification of the amount of localized energy that brainwaves have compared to what they would have in, say, a normal flat space. So going into the technology side, it is critical, and yeah, it can supersede what the brain can do on its own. This is way beyond your normal meditation, telepathy, and that kind of stuff. This is technological implementation of brainwave science. That goes way back through Montauk and the Philadoc. They experiment what the terrible things are that they learned there. Yeah, we can trace this back through MK Ultra and MK Delta. There are many historical freaking markers along the historical train for government implementation of programs from the CIA and upwards, looking at human psychology in a very serious format. And there are even patents that get way out there. Well, I shouldn't say patents. I should say patent applications.
Should we filter that? Should we filter the person that they
No,
have
we should
done this on?
all, as individuals, look at all the information and make that decision for ourselves. We should look at John Quincy Sinclair's crazy patents about human teleportation system, and various things like that. We should seriously consider whether or not there might be veracity to it, even if they were only patent applications. We should all look at that individually and say, does this stuff make sense to our worldview? Can we see these technologies actually working? Please don't look at that one. Yes, look at the magnetic wormhole generator or the rotating electromagnetic field system. The walking through walls training system is a weird one. I mean, this is about as weird as it gets in terms of patent applications that I can reference. This guy thinks that if you step perfectly right in perfect synchronous time and move at a specific forward velocity through what he measured through his calculations, his flat space-time metrics, that you can generate a torsion field within your own chakras. Not shitting you, this is in the patent. And you're able to walk through solid matter by synchronizing with the stress energy momentum tensor of your surrounding space-time.
Yeah, I've heard that in ancient stuff, like all of these big stones, megaliths that are doors, but they're just stone. Well, yeah, they manipulated the energy to where the stone became loose, like it's not loose, lucid, transparent into their world. Their world, either they were tunneling.
It's crazy.
Or they were like going on to the atomic structure of the DNA in the stone.
Yeah.
Into that timeline.
Like, I mean, when we're talking about tangible technologies, what we're looking at here in this patent, this weirdness that Jeremy's kind of scrolling over in the background, this is basically a piece of software that he's patenting. He's not patenting an actual system or technology. He's patenting a piece of software that calculates based on your body mass and your height, in your mass distribution, what the length of the stride of your footsteps needs to be printed out on a dot matrix printer, so that you can walk through walls if you follow it at exactly a synchronized stopwatch pace as you step forward one step at a time. That's what he's patenting here. It sounds as crazy as it is. It is crazy, but it basically says if you follow these footsteps on this printed piece of paper, all put in a line, and you walk exactly this pace, steps per second, yeah, you'll walk through walls. That's what
That
he's saying.
sounds like disinformation or something, man. So
It
bad.
sounds crazy, but you're gonna find out later on down the line that a lot of the stuff this guy put out is kind of spot on, especially like the electromagnetic wormhole generator.
That John St. Clair guy, you think?
Yep.
Is on? Yeah.
I built an electromagnetic wormhole generator. That thing is weird, man.
Fine, but we'll see. Man, I would like to see all this stuff. All right, guys, if you got some cool experiments, save them for next time. I'm going to bed, and let's do this again another time and more often and than not.
Cool.
See what we can come up with. All right.
Sounds good, dude. Thanks for coming on and hosting the show again. I'm sure your audience appreciates the deep down technology info.
I love this group. You don't understand. Like, my gosh, the rest of the world seems trivial. Like, it just makes you disgusted. Really. Like, once you know so much.
We know, man. We try to rock it because technology is for real, and we don't really care what anybody says. And I get you're just trying to rock it too. You've seen time displacement. I know what you've been through. I watched your case study and checked out what you've seen as far as your local time displacement, price displacement, and clock desynchronization. So yeah, I watched and looked into your case
They
study.
mess with me, dude. They mess with me. Yeah,
Not as far as I could see. No, what it looked. I wasn't sure what the catalyst was, but it looked like your data did suggest the idea.
Honesty,
that you control
it
displacement.
increases entropy. Entropy manipulates piezoelectric things and stuff, you know? And so time moves faster. Well, if it's not on manual, it's like on auto, which is supposed to be synchronized on everything. Well, guess what? I move faster than time. Like, I'm always ahead of time on different things. And then when you try to correct systems to teach these people,
You've
like,
got to
hey,
focus on proving it, and that's the thing is that
Oh,
you're
I
going to find
do.
us
I-
scientists like us nerdy guys that do all the engineering and the building and the constructing of stuff. We've got to prove that our observations are true, and we
no,
have to use
I
test
do.
measurement equipment.
I prove
I know
it.
I've seen your receipts. The receipts are part of the case study. I have considered those.
My receipts.
We
How do
need,
you
we
know?
need
How do
something
you
that
know about
even
my
goes
receipts?
beyond that. It's almost like you have to sort of subject the system to scrutiny itself, subject the clocks that are on your cell phone and the way that you actually record that time to scrutiny itself. And it's one of those things where we need tangible evidence that's going to be acquired by using analog technology, like say a pocket stopwatch or something on those lines.
No, you first stack them up by date, and then you cross-reference the digital and show where the discrepancies are. It shifts in time.
Anyone want
It
that?
manipulates things on its own.
Drive that we were showing
You
off.
know, I'm telling you, it does.
Sorry to cut you off. I want to
Yeah, this
wrap
drive
this
is nuts,
up.
dude.
Trying to wrap up the stream and end it. All right, and people want to come on. I shared the link here. Come
Yeah,
on.
I get it, man. I get it.
Stream.
Let's go on. Let's go on to the nitty gritty of the physics.
We
Okay,
can
the
move this-
physics of
we can
flying
move
saucers.
discussion
Just
to backstage. All right, and I'm going to end the broadcast now. Anyone wants access to those documents that we were showing earlier, please join, and I'll get you guys hooked up with those. So thanks for watching. Have a good night.
see you in the